So in 4.8, what we're really looking at is we're going to have to be able to factor this first and then be able to graph it by our intercepts. So if I'm looking at this equation, remember I have my diamond. I'm going to have my diamond, and at the top is going to be my last term, which is 5, and then at the bottom is going to be my, there we go, is going to be my middle term, which is -6. So what are factors of 5 that equal -6? Well, that's -1 and -5. Two negatives make a positive, and so -1 plus -5 do equal -6. So I know if I were to say y equals, or f of x equals, same thing, then I get x minus 1 times x minus 5. Now from here, I can easily see that my p equals 1 and my q equals 5. And if I were to graph that, I have p at 1 and q at 5. So now what I want to do is find my axis of symmetry. If I look right in the middle, okay, then it is at 3. If you want to, you can always do p plus q divided by 2. But I see that it's at 3. I know that my vertex, didn't want to do that. I know that my vertex, not my vertex, but my slope is 1. And so when I want to try to find my vertex, I plug in that axis of symmetry, which I know x equals 3, into my equation. So I get y equals 3 minus 1 times 3 minus 5. And 3 minus 1 is a positive 2, and 3 minus 5 is a, that's a time symbol, is a -2. So 2 times -2 is -4. So my vertex is going to be 3, -4. Alright, so if I were to take that 3, -4, I know that's going to be down, let's straighten this out. I know that's going to be down here. And since my slope is 1, I go up 1 over 1, and I can check that that does indeed go up 4 over 2. So that would be my graph. So let's actually look at, on your next page, page 31, let's look at number 3. Okay, so if we're looking at number 3, there's something I can automatically do. I can automatically take a 2 out. So if I were to factor out a 2, I get y equals 2 times x squared minus 6x plus 8. And if I have 2 times x squared minus 6x plus 8, I can now factor this x squared minus 6x plus 8. I have 8 on the top and a -6 on the bottom. Alright, so an 8 factors of 8 is -4 and -2 that add up to -6. Alright, well, if I were then to rewrite that, I get y equals 2 times x minus 4 times x minus 2. Now, my p and q are then a positive 4, right, and a positive 2. So if I were to plot a 4 and a 2, I'm looking at my axis of symmetry, which is 3. So I'm going to plug 3 in. So I get y equals 2 times 3 minus 4 times 3 minus 2. Then I get 2 times 3 minus 4 is -1. 3 minus 2 is 1. So I get, all in all, -2. So my vertex is going to be at -2. Right, it'll be at 3, -2. So because my axis of symmetry is at 3. Now, if I want to double make sure, that's not 3, 4, that's 3, -2. If I want to double make sure, I'm looking at my slope, and the slope of my line is actually 2. So if I go up 2 over 1, that's my next point, and then I'm going to be going up 8 over 2, which would be all the way up here, and that would be my next point. So this is what your graph, well, mostly like that, as best as you can. Let's try one more. Didn't want to do that. Let's try one more. What if I went on to number 4, and what's something I can take out? Well, I have 2x that I can take out, right? And even more so a -2x. So it becomes an x plus 2. All right, so I have an x plus 2, that's y equals -2x times x plus 2. So something that we do here is that to be able to find our x values, what if I equal this to 0, right? That's really saying that our x value is equal to 0. So then if I split it up, right, according to this is my a, This is my b, and I can split it up. So I have negative 2x equals 0, which if I divide each side by negative 2, I get x equals 0. And then I have x plus 2 equals 0, and if I subtract 2 from each side, I get x equals negative 2. So my vertex, or not my vertex, my intercepts are at 0, right? 0 and negative 2. So that would be where my two intercepts are. Now if I'm looking at my axis of symmetry, my axis of symmetry is where x equals negative 1. Now I have to plug negative 1 back in. So I'm going to get negative 2 times negative 1 times negative 1 plus 2. Alright, negative 2 times negative 1 is a positive 2, and negative 1 plus 2 is a positive 1, so I end up getting 2. My vertex then is going to be a negative 1, positive 2. So looking at this, negative 1, positive 2, if I were to look at my slope as well, and I look back to this equation, my slope is negative 2. So I should be going down 2 over 1, which I do, and I'm going to go down 8 over 2 instead of down 4 over 2, because it is double that. So this is what your graph will look like. So let's jump to number 7. Real quick, because 7's a little bit odd. 7 is y equals 1/2 x squared plus 3x plus 5/2. Something I actually, want to get rid of is that half. So I'm going to factor that out. I'm going to factor out a half, so I get x squared plus, 3 divided by 1/2, right? I'm dividing everything by 1/2, becomes 3 over 1, flips get multiplied, times 2 over 1, which equals a positive 6 over 1, or just a 6. So I get 6x. All right, then plus if I factor out, a half from 5/2, which would be 5 halves divided by 1/2, I flip skip multiply. So I get 5 divided by 2 times 2 over 1, which ends up, these cross out, which ends up equaling 5. So you get 5 at the end. So now this is your new equation. Alright, so this is the new equation you're working with. Well, I can do that, right? Now I just have to factor. So what are factors of 5 that add up to 6? Well, 5 and 1, or 1 and 5. That's all you got. So it's going to be a 5 and a 1. So I'm going to have 1/2 times x plus 1 times x plus 5. Now I can graph my p and q. My p equals negative 1. My q equals negative 5. And so if I were to graph that, I have negative 1 and negative 5. If I want to find my axis of symmetry, it's right dab smack in the middle. So my axis of symmetry is when x equals negative 3. Now, with that negative 3, I'm going to plug it back into my equation. So I'm going to have 1/2 times negative 3 plus 1 times negative 3 plus 5. So I have 1/2. Negative 3 plus 1 is negative 2. And negative 3 plus 5 is a positive 2. So I end up getting a 1/2 times negative 4. And then 1/2 times negative 4 equals negative 2. So my vertex now is going to be negative 3, negative 2. So at negative 3, it's negative 2. I have a positive slope, but my slope is 1/2. So instead of going up a full 1 over 1, I'm going to only go up a half, right, and over 1. And then I'd have to go up 2 over 2, which my graph ends up doing. So this is my whole graph. Alright, so for 9 and 10, it's saying write the equation in intercept form for the parabola show, then convert it into standard form. And standard form, remember, is ax squared plus bx plus c. And so that's where you want to convert it. So we're going to start out with finding our p and q. And so our p and q, if we're looking at this, is, a little bit straighter. Our p and q is going to be 2 and 6. So I know, and looking at my slope, it's 1 over 1. So I know that y, or f of x, equals, it's going to be x minus 2 and x minus 6. Right? And then I'm going to have to get it into standard form. I'm going to have to FOIL out. So I have x times x, which is x squared, and then x times negative 6, which is negative 6x, x times negative 2, which is negative 2x, and then negative 2 times a negative 6 is a positive 12. And so that simplifies to x squared minus 8x plus 12, and that would be your standard form. So you could say f of x or y. I know it's interchangeable, so I'm just going to show you both, but that would be your final form. Now, you could also, just say your vertex is what? Your vertex is going to be 4, negative 4. Well, if you really want, you can plug it into f of x equals, right, x minus 4 squared minus 4, right? That was our original vertex form. So remember, there's absolutely 3 ways you can write this, and you have to kind of know all 3. I'll do number 10, one more with you. First, I'm finding my p and q, which is 1 and negative 1. So if I were to write f of x equals x minus 1 and then x plus 1. But here's the thing. From here to here, what's my slope? It's down 2 over 1. So there's actually going to be a sneaky 2 out here. If I were to now write this in standard form, I want to go x times x, which is x squared, x times 1, which is 1x, so plus x, x times negative 1, which is minus x, and then x plus 1, negative 1 times a positive 1 is a negative 1. And I still have all of that times by 2. So I have f of x equals 2 times all this jibber jabber. Now, positive x minus x, well, those cancel out. So I end up getting 2 times x squared minus 1. Right, that's f of x. It's almost standard form. It could be close, but to forget standard form, you have to multiply everything out. So it ends up being 2x squared minus 2. That would be your standard form. Something I haven't looked at as well is this a happy-go-lucky or negative Nelly? And, it's a negative Nelly. So actually this 2 is all negative 2, and it doesn't really matter until you get to here, because then it makes that a negative and switches that to a positive. So it becomes negative 2x squared plus 2. Again, if you want to write in vertex form, find your vertex. Well, your vertex is at 0, 2, and then if you plug it in, you have f of x, right? And it's negative 2. Your slope is a. Then it's going to be x minus 0. There's no h, so it would be x squared. And it's going to be plus 2. You could have written it like that too. And then after multiplying that out, that also becomes in standard form.